Okay, geometry students, I appreciate you finding time to get your notes taken care of. Today we're going to continue on with our discussion of circles, and we're going to look specifically at one of our new structures that we have discovered here in recent days, and that would be the tangent. So today we are talking about properties of tangents. Please copy down your title as well as your objective. Our objective for this day is we will learn the properties associated with tangents, and how they interact with circles. As always, press pause anytime you need more time to get your notes copied down, and then hit play whenever you're ready to move on. Okay, so let's have a brief review of what we know about tangents. Okay, tangents are lines, okay, or lines will be tangent to a circle, okay. They intersect the circle in such a way that they are going to be perpendicular to the radius of the circle. Okay, now obviously a tangent can intersect the circle anywhere, but of course a radius can be positioned inside of the circle anywhere as well. So no matter where the point of tangency is, there will always be a radius to connect the center to the point of tangency, and that intersection between the radius and the tangent will always be a right angle. So of course, anytime we have right angles, just like all year long, okay, we have the possibility of right triangles. So we could connect the center point of the circle out with a point on the tangent somewhere, and you can very easily see the right triangle constructed between the tangent and what is trying to be a secant between A and C and the radius. So wherever we have right triangles, that of course opens up the possibility of Pythagorean theorem, SOHCAHTOA, all that good stuff. Okay, so what we're probably going to see if we face questions like this is we will end up facing some word problems, and we'll get to that. But let's take a look at the basic math first. Okay, here's a problem dealing with tangents and the property of a tangent and a radius forming a right angle with each other. Okay, now clearly you can see the right triangle that is in there. This is nothing more than a fancy Pythagorean theorem question. As we've said in geometry, the math does not get harder. Okay, the problems get harder, the pictures get harder. Okay, the diagrams get more cluttered. Sure, there is a circle inside of this diagram, but it does not change the fact that this is still a right triangle. Okay, so since it's a right triangle, we can apply Pythagorean theorem. We know two sides of our triangle. Okay, all we got to do is get the hypotenuse positioned correctly. Okay, so which of these three sides would be the hypotenuse? Okay, hypotenuse is always across from the right angle. That would be the A, meaning the 2 and the 10 are the legs of the triangle. A is the hypotenuse, and you should be pretty much in the clear at this point. 2 squared would be 4, 10 squared would be 100. A is unknown, so we'll just leave him alone for a moment. We can combine like terms on the left side of the problem. 100 plus 4 is 104. And then the only thing really left for us to do is to get the square off of the A, and we would do that by taking the square root of both sides. Okay. Now at this point, if you remember back, what we would need to do is we would need to factor down the 104 into all of his factors to see if we can find any factors in common. Well, when you get finished factoring 104, actually what you'll end up with is 3 2's and a 13. Okay, we are looking for pairs of stuff. Obviously, there are a pair of 2's in there, so 2 of those 2's will join together and come outside. We will have a 2 outside of our radical. We will have a leftover 2 and a 13. Okay, they will recombine and they will make a 26. So the length of A is exactly 2 times the square root of 26. Okay, that should be very much review math from the fall semester. Now the real challenge is going to arise, as I said, when these things start showing up as word problems. So let's take a look at that. Okay, this is a typical type word problem that might show up with the idea of a circle and a tangent interacting with each other inside of a problem. Okay, you are standing 8 feet from a cylindrical tank. It is 20 feet to a point of tangency. What is the radius of the tank? Okay, now while you're copying that down, I'm going to go ahead and talk into your ear here and say that, you know, the most challenging part of some of the word problems in geometry is, of course, transferring the words into a picture. We've said all year long that our brains understand pictures better than they understand paragraphs. So we want a diagram. They did not give us a diagram along with this, and that's one of our basic strategies. If they didn't give us a picture, we're going to draw a picture. So let's see if we can figure out what this thing would actually look like. Okay, so it says you are standing 8 feet from a cylindrical tank. Okay, now think about the nature of standing in front of something that is round. Okay, like a big can sitting on the ground. If they say 8 feet to a tank, would you measure straight over to the tank? Would you measure way off to the very edge of it? No, of course not. You'd measure directly to it. 8 feet from it would be the closest point between you and the tank. So that would be straight over to it. Then it says 20 feet to a point of tangency. Well, you better know where the point of tangency is. And that, of course, would be kind of way over at the side of the tank, almost where the tank is turning away from you, kind of where you'd lose sight of it, and then it would turn and go back around behind itself. Okay, so if you are thinking along those lines, okay, then what we are looking at is a diagram that from above would look something like this. You're standing there, it's 8 feet from you to the cylinder, and it is 20 feet over to the very far edge that we can see, which would be the point of tangency. Okay, now obviously that is not enough information for us to do anything about it, but we know good and well that if we could find a way to turn this into a right triangle, then we have things like Pythagorean theorem and SOHCAHTOA that can help us out. Okay, well, if we were to add in a couple of radii into this picture, you would see that it would actually finish off a right triangle. And of course, we know it's a right angle at the point of tangency because of this property, where the radius and the tangent are going to form a right angle. Okay, and the radius kind of reaching out to that 8 feet where it's measuring from us to the tank. Okay, that radius actually helps us finish off the hypotenuse of that triangle. Okay, so you can see the triangle in there. We've just got a little bit of new math that's going to happen. Okay, so let's take a look. There's the triangle. I took it out of the circle just so we could see it uncluttered. Okay, let's think about the Pythagorean theorem. Obviously, our legs are r and 20, so we will have r squared and we will have 20 squared. Okay, but what about the hypotenuse? Okay, a part of it is r and part of it is 8. Okay, well, we cannot add r and 8 together because they are not like terms. So the length of our hypotenuse is actually whatever r plus 8 actually is. Okay, so just plugging into Pythagorean theorem, here is what we would know at this point. Okay, now clearly on the left, r squared, we don't know anything about him, so he's going to remain r squared. 20 squared is actually 400. Now, over there on the right side, we have a binomial, a two-term expression, okay, that is waiting to be squared. Now, think back to your days in algebra. What does it mean when a polynomial, or anything for that fact, gets squared? It means to multiply that thing times itself. So over on the right side of the problem, you have r plus 8 times another r plus 8. Okay. Now the next step would be going, okay, r plus 8 times r plus 8. What actually is that? Well, again, thinking back to your Algebra 1, to multiply a binomial times another binomial, we basically do probably what your teacher called the FOIL method. Okay, where from the first binomial, the r needs to multiply by everything in the r plus 8, the second polynomial, and then 8 from the first polynomial needs to multiply by everything again from the second polynomial. So we're going to get r times r right here. We're going to get r times 8 right there. We're going to get 8 times r right there. And we're going to get 8 times 8 right there. The result of that multiplication is r times r is r squared, 8 times r is 8r, and 8 times 8 is 64. Okay, now this is probably looking very complicated to you at this point, but I assure you it's about to get much, much easier. Okay, now if we were to combine like terms, start combining like terms, well, did you notice that there are r squareds on the left and there are r squareds on the right? There's no reason for them to be separated like that, so we would try to combine them. So if we took one of the r squareds, okay, I'm sorry, the next step that I did was combine over there on the right side, 8r plus 8r is 16r. Sorry, I misled you there for a moment. Now on to the r squareds. If I decided to move the r squareds from the left over to the right, that would mean subtracting r squared from the r squared on the left. Okay, but whatever we do to one side of the problem, we have to do to the other side. But look what happens. There was one r squared on the left, there was one r squared on the right, so by subtracting r squared from both sides, now look at the problem. 400 equals 16r plus 64. That's much more manageable, and we can probably get it from here. Okay, our r's are over on the right. Okay, so the plus 64 does not need to be over there with them, so we would move the plus 64 by subtracting it. Of course, whatever we do to one side, we must do to the other. Okay, that would leave 336 on the right side, or the left side, pardon me. And on the right, we have 16 R's, but we do not want 16 of them. We just want one. So we would divide both sides by 16, and the radius of your tank is 21. That's actually pretty powerful mathematics right there. We just accomplished the radius of a tank without having access to the interior space or without being able to measure the circumference. Okay, that is a cool calculation right there. Okay. Not all the problems are that complicated, but you get the basic idea. Now, there is one other rule that goes along with being a tangent, and this one is kind of common sense, but I give you the common sense rules as well. Okay, and this one basically states that if you have two lines that are tangent to the same circle from a common endpoint, then the lines are going to be congruent. Okay, I'll never give you a definition without giving you a diagram to match it. Okay, so here is a diagram of what is being stated in that rule. Okay, and this one probably is a little bit of common sense, like I said. If you begin from a common endpoint and get used to that common endpoint idea, there's a lot of rules that we're going to see with circles here in the next few days that do this common endpoint thing, like A in this particular diagram is a common endpoint, meaning two lines are joining together at the same location. Okay, this rule is simply saying, oh, if you begin from that location and go to either point of tangency from that location, then the lengths of those line segments connecting to the points of tangency, they are going to be congruent. So in this case, line segment AC is congruent to line segment AB. Okay, that is all. I do not actually have any new or extra problems for you to work out, so I do appreciate you taking the time to get your notes taken care of, and I will see you in class. We will practice this a little bit further. Have a good night.